Okay, we're working on problem 20C from section 13.3.
And I believe also
Okay.
the experience.
So let's pull up the whiteboard.
helps you to
We're
know
supposed to find the
who
distance or
and
find the length.
experience
from
comes
A to B.
seeing.
A is our point -1, 2, and B is 3, -4. I think I'll go over to actually Desmos so that we can see this on a grid. So let me share here, and I'm gonna go into desmos.com. So please go to desmos.com
And to know the whole experience.
and we can draw in our points. Actually, on Desmos, you can tell it with the ordered pair and it graphs the point for you. So can you both see my Desmos coming up?
Yes.
Okay, so what I have here is the point -1, 2. So it's back 1, up 2. And the other one is 3, -4. So it's to the right 3 and down 4. Okay, so can you both see those 2 points plotted?
Yes.
Okay, now to get the, do you have any ideas on how you could get the distance between those 2 points?
Draw a straight line.
Yep, if we put in a straight line, if I could actually draw a straight line. Once you put in your straight line though, how could you find the distance? Any thoughts on that? Like what tool could we use to find that, well, hint, diagonal distance? How can we
Aaron,
find?
you're muted. Aaron, you're muted.
Can I
I'm-
go out on the limb and see the Pythagorean theorem?
Yes. We
Okay,
put
that was a
that-
stretch. I just thought that. Okay,
Yep, diagonal distance, be thinking Pythagorean theorem, kind of like on that 4√2 question. I was thinking Pythagorean theorem, diagonal distance.
Sure.
Okay, so in order to get our right, because you need a right triangle, right, for the Pythagorean theorem. I'm just gonna draw a horizontal segment and a vertical segment to make a path from one point to the next. So there's my right triangle. So now I just need to figure out my length and my width, or the base and the height on this triangle, and then I can find that diagonal distance. So what are those base? What is the base and the height if we know that this is the point 3, -4. And up here we have the point -1, 2. So what is my horizontal distance here?
it would be 1, 2, 4.
And did you just do that by counting or did you use these X values? I mean, it's right, it's 4.
I know, I used my 3rd grade math skills and
You just
I
counted. Okay.
a number line.
If it was really big numbers or decimals or something like that, you could have just subtracted and taken the second X minus the first X. So 3 minus
Nor
-1
do we care.
is actually,
Most of us
4.
don't even care.
so the second X, oh, I meant that to be the first X. So the second X minus the first X would be 3 minus -1. So in this case, it's 4. Now, how about the height of that triangle? Can anybody give me that?
It would be y2 minus y1, which is -4 minus 2.
-4 minus 2. Of course, we know it's a length, so it won't be negative. So it's a length of 6. But we can call this the second Y minus the first Y. Now, on the Pythagorean theorem, we're gonna square the 4, add it to the square of the 6, and take the square root of both sides, right?
Right.
4 squared plus 6 squared equals, I'm gonna call it V for the distance. Distance squared. That's gonna give me 16 plus 36 is the square root of, is that 52?
It is
Yeah. 52.
52.
Now, the question is that divisible by a perfect square? Is 52 divisible by 4?
Yes. 4 times 13.
Okay, so we can simplify that into root 4 times root 13, and the square root of 4 is 2. And so our distance is 2 root 13. So to find a diagonal distance, it's just a simple process of drawing a right triangle and using the Pythagorean theorem. But their mathematicians have made a formula to figure this out. So if you want to use the distance formula, you can. And it just comes from this Pythagorean theorem. Here, this horizontal distance we figured out was the second x minus the first x. And to put that in the Pythagorean theorem, we would have to square it, right? Added to the square of the other side. We took the second y minus the first y. Or in our case, we could have done the first minus the second, so it would have been positive.
And we're right,
And that's gonna equal your
and we're
distance squared.
writing a whole new Sunday school.
And then you just take the
Based
square
on
root of both
that.
sides, so your distance
I don't
is the
get it
same
from,
thing as
you know,
the square root of the second x minus the first x. Quantity squared. So x2 minus x1 quantity squared plus, and then we have the other side. We're taking the second y minus the first y, and we take that quantity squared. You've got the square root of the whole thing, and bam, there's your distance formula. And if you plug in the ordered pairs, you get the exact same thing as we got when we drew it with the right triangle. So it's completely up to you whether you want to use the distance formula or use the Pythagorean theorem. Either way, you can put the formulas on your note card.
we've got the funding,
But there's some people that,
from
really
what
do
the
prefer the
president
Pythagorean theorem. Others prefer using the distance formula. If you're programming a computer or
So that's what I'm saying.
a
funding, they are
graphing calculator, sometimes the distance formula can be the better option. But for myself, I really like the Pythagorean theorem method and just drawing the
Well,
right.
it's kind of easier just to remember one than trying to figure out, because you're using the same numbers, right? So
So anyway,
look, I get my plug out because I thought it was my computer saying.
no, mine is about to run out of charge.
Oh, I was in here checking mine. I'm like, mine's plugged up. What does it do?
And I'm
Did it
like,
show
mine
you
has
that?
never done that to me before. Usually it comes up